All right, let's take a look at the Unit 5C Learning Targets 17 through 20 review. This is the last set of learning targets we need to test on before the final exam. Learning Target 17 says, I can predict the products and write a balanced chemical equation for a neutralization reaction. We have learned that neutralization reactions are when you have an acid and a base and they make salt and water. So for letter A here, I recognize that since this one starts with an H, that must be the acid, and this one ends with an OH, this must be the base. I know without even thinking that it's going to make H2O. And that makes sense because the H is going to be with the OH. And I'm not going to worry about balancing yet. I'm also seeing that Al is going to be with the NO3. And I need to check charges. Aluminum's got a +3, and NO3 is a polyatomic ion with a -1. You will have a polyatomic ion chart. So I crisscross the charges, and this makes AlNO3 3. Now this is not balanced. So I've got 3 NO3s, so I'm going to put a 3 in front of the NO3 on the left. And then let's count out how many total H's. So I've got 3 H's here, plus another 3 H's here. That makes 6 H's. So I need a 3 in front of the H2O, so that makes 6 there. O's, I've got O3 right here, and I've got 3 O's here. And then there's more O's with the NO3, there's 9. And then there's 3 times 3, 9. So now everything's checked. This is a balanced neutralization reaction. All right, let's take a look at letter B. I can see that this starts with an H, so that must be the acid. This one ends with the OH, so this must be the base. Without even thinking, I can write H2O. And then what else is left? I've got Na, which has a +1 charge. And I've got CO3, one of my polyatomic ions. It's got a -2 charge. So I'm going to crisscross the charges. Na2CO3. Now I need to balance. I've got 2 Na on the right, so I need a 2 over here. And then I've got 2 H's here plus another 2 H's here. That makes 4 H's, so I need a 2 in front of the H2O. Now I'm fully balanced. Learning Target 18 says, I can calculate the concentration of a mystery acid or base given data from a titration experiment. So here we go. A titration requires 150 milliliters of 0.5 molar NaOH to neutralize 250 milliliters of an unknown concentration of sulfuric acid. What is the concentration of this acid? Step 1. Write out the balanced equation. NaOH plus H2SO4 makes, we just did a bunch of these. We know it's going to make H2O. And then what else is left is Na, which has a +1, SO4, which has a -2. So Na2SO4, which means we need a 2 out front and a 2 in front of the H2O to balance this. Now, my next step is to write what I know underneath each chemical. I know I've got to add 0.15 liters of a 0.5 molar solution of NaOH in order to neutralize 0.250 liters of a question mark molarity of H2SO4. What I did to get milliliters into liters was divide each of these by 1,000. Third step, I'm going to multiply liters by molarity to get the number of moles of base that I needed to add. 0.15 times 0.5 is 0.075 moles of NaOH. And from my balanced equation, for every 2 moles of NaOH, it neutralizes 1 mole of H2SO4. I got the 1 from out front right here where I'm circling. So I'm going to cut my number in half here. 0.075 times 1/2 That's 0.0375 moles of H2SO4. And then there's one number I haven't used yet. I need to find the concentration, which is moles per liter. So divide by 0.250 liters. The concentration of my mystery acid was 0.15 molar H2SO4. Learning target 19 we did in class. Could you perform a titration and determine the endpoint? Learning target 20 is the last one. This has to do with reaction rates, which is kinetics, and collision theory. So it says, imagine you have the following materials to use: powdered zinc, lumps of zinc, hydrochloric acid, 1 molar and 2 molar, a hot plate, an ice bath, a stopwatch, and a catalyst. You run a bunch of experiments to try to answer all the questions below. What results would you expect to see? An increase or decrease in the rate of reaction for each of the following, and why? What is the effect of decreased concentration of hydrochloric acid on reaction rate with zinc? If the concentration goes down, like if I did the 2 molar and then the 1 molar, I would expect to see a decreased reaction rate. And the reason is, in that lower concentration, that means there's less solute particles for the zinc to collide with. There are less HCl molecules for the zinc to collide with. And therefore, that will slow down the reaction. For letter B, what is the effect of decreasing temperature of the acid on the reaction with zinc? Once again, I would expect a decreased reaction rate, because if there's a lower temperature, that means the molecules, the HCl molecules, move slower and collide less frequently with the zinc. Which is going to slow down the reaction rate. What if I added a catalyst to this reaction? I would expect the reaction rate to increase. And this is because catalysts lower the activation energy, which makes it easier for the reaction to proceed, and it speeds up the reaction. There's different mechanisms, like the catalyst is able to bring the reactants together or in the proper orientation. And so it's a little bit vague on the exact mechanism here because different catalysts work in different ways. And last, what is the effect of increased surface area of zinc on the reaction rate? I would expect an increased surface area to speed up the reaction rate. So the powdered zinc would react more quickly with the hydrochloric acid because the HCl can collide with and surround the powdered zinc much better than the lumpy zinc. So the reaction will happen faster. All right, that's it for these learning targets.